10b looks at Pythagoras' theorem in 3 dimensions. It works the same way as 2 dimensions, except that you need to apply it twice. So for the first example, we've got a cube, and it has a side length of 5 centimeters, and we're asked to find, correct to 2 decimal places, the length of AC, which is this bottom diagonal in here, and then correct to 1 decimal place the length of AD, which is this one here. So, to start off with, draw your triangle. So, first step, draw your right angle triangle that includes that length. So the length is AC, which means I'm going to draw this bottom triangle ABC, putting in my lengths, and then solve it using Pythagoras. So the length AC is the square root of 5 squared plus 5 squared. This can go into my calculator, so square root of 50. And because I want 2 decimal places, I will get my decimals out to get 7.07. This is centimeters, so placing centimeters there as well. So part A done. Part B, AD. Now you're going to have to use the result that we just found. So the triangle is ADC, where we use a height of 5 and the length AC of root 50. Now, it's really important that you use root 50 and not 7.07 because you'd have error if you used 7.07. So into my calculator, I am going to put root 50 and then square it. So that's what I'm going to chuck into my calc. And when I do that, I need to get my result to 1 decimal place. So 5 root 3 is my exact value. As a decimal, this is 8.66. which in 1 decimal place is 8.7 centimeters. Done. Example 2. So example 2 is a pyramid example. We're first asked to find AC, and then we're asked to find the length of EF, so that height of EF. So part A, 2 decimal places for AC. So again, draw your triangle that includes the AC. So this is an ABC triangle with side lengths of 25. So square root of 25 squared plus 25 squared is going to give you the length of AC. Again, that's calculator. And we get out 35.36. And this is centimeters. Now, in order to do part B, you are going to have to use your previous answer, but you need to half that answer. So the length of the hypotenuse is 26. We've been given that, but the length from A to F is half of A to C. So it's going to be 25 on root 2 divided by 2. Now I am using that exact value, 25 root 2 on 2, and not the 35.36. Because you've got your calculator, it's easier just to go up and highlight and grab your result from there. So you don't have to retype stuff. I think I'm about to retype it. But yeah, you don't need to retype stuff. So you just highlighted it. And now I'm going to square it. And I've got an error because I haven't divided by 2. So 25 root 2 needs to be divided by 2. And that gives me 19.0657. And I want 1 decimal place, so 19.1 centimeters. There is a shortcut to doing part B. So if you weren't asked to do part A first, which is this length AC, the shortcut to do this is to actually take certain side lengths and square them, add them together. So for instance, looking at this, this is our shortcut. So if you've got a rectangle and you're after this distance, for instance HB, then you can say that HB is actually equal to AB squared, AD squared, and DH squared. So the 3 side lengths that take me from B to H. If you square them all, add them together, and then take the square root, you'd actually have this side length of HB. Otherwise, you just use your two triangles like normal. Neither way is more correct. It's just a shortcut. Example 6 is just a practical example of 3 dimensions. So we're looking at a room with the dimensions 4 by 5 by 3, and we're trying to run some cabling basically from A to G, which is one diagonal to the other diagonal. Now you wouldn't have cabling going through the middle of a room, so we are going to go along the edges. So A, B and C are looking at these scenarios. Part A is the length of cabling if we went from A to E, E to H, and H to G. So we're basically running along the edges of the room. We're not doing any diagonals. So the length of cabling is just going to be that 5 meters and the 4 meters and the 3 meters added all together, which will give us 12 meters of cabling basically. That's all part A is asking for. Part B is now looking at going from A to F, so this diagonal here, and then across the top 4 meters to G. So A to F is the square root of the bottom and the side, so A to F is 5 squared plus 3 squared, and then take the square root of that to give us approximately 5.83. And then that we add 4 to get the length of F to G. So A to F, F to G ends up being approximately 9.83 meters. That's part B. Part C now says if the cabling costs $9.10 per meter, which is the cheaper option, A to F to G or A to E to G. So A to E to G, we still haven't actually calculated the E to G portion. So that's what this square root 4 squared plus 3 squared is. And when we actually go through and do this, we get out, it's just over 10, I think. It's equal to 10, full stop. So what we can say is that the length from A to E to G is 10 meters versus A to F to G, which is 9.83. Without actually calculating a dollar amount, I can say that this option, AFG, is cheaper because there's less distance. So I'm not actually asked to calculate the cost, I'm just asked to calculate which one is cheaper. So that gives me AFG.